In this example, we will demonstrate how to parameterize a simple model on the NECADA website. First, you need to select a building model, which consists of the BIM data for your building. In our case, this data is defined using the IDF file format from Energy Plus. This widely used format allows for the definition of building geometry, as well as the materials and construction solutions, among other parameters. If you own your model, you can easily upload it to the platform. If you do not have a model, NECADA provides the option to generate simple models using the cadastral data. In this example, we will use our own IDF file, named IDF_OK. The materials and construction solutions are stored in a dedicated database on NECADA. Users can access this database to obtain relevant information and incorporate it into their experiments. Along the material, the database contains constructing solutions that allows to detail the composition of the different building structures we will simulate. Additionally, we can specify the climate file, which is essential for understanding the effects of climate on our building. We will also focus on various aspects of sustainability, specifically by examining environmental process indicators associated with materials and construction solutions. This includes a detailed analysis of the costs related to their management, as well as material-specific environmental indicators. These elements are crucial for effectively measuring sustainability, as they provide tangible metrics that can inform decision-making and project planning. Once we have defined the parameters of our model, we can formulate a project that encompasses several experiments aimed at comparing different scenarios. Each scenario will provide valuable insights into the effectiveness of the various alternatives we analyze concerning our buildings. Initially, it is essential to establish a name for the project and assign the appropriate base building information modeling (BAM) model to be utilized. In our specific case, as we are uploading a new model, the system performs a check to ensure there are no errors in the building IDF format. This process includes executing a default experiment named BM validation reports. When this validation is successful, indicating no errors, we can then move forward with defining the various experiments to be conducted. These experiments will collectively enhance our understanding of how different design alternatives impact our building's performance, ultimately guiding us toward more effective solutions. Each experiment will be meticulously designed to capture critical metrics that will inform our decision-making process. At this stage, we have successfully validated our building information modeling (BIM) model, making it ready for rigorous experimentation. With the validation complete, we can return to our experimental framework to finalize the parametric setup. This involves meticulously defining each parameter that will guide our experiments, ensuring that they align with our project objectives. By doing so, we can explore a variety of scenarios and assess how these variables impact the overall performance and sustainability of our building design. This step is crucial for generating reliable insights and drawing meaningful conclusions from our experimental analysis. We can associate various construction solutions with the building and explore different permutations and weather data among other parameters. In this example, we will focus on analyzing the impact of the building's orientation, particularly in the context of new construction. This analysis will consider several crucial factors, such as energy consumption, natural light exposure, and thermal performance. By examining these variables, we can gain insights into how orientation affects the building's overall efficiency and sustainability. Once the parameterization is complete, incorporating the orientation, building, and weather information we wish to analyze, we can execute the model. The duration of this execution depends on the number of final scenarios generated from the combination of value factors. In this straightforward example, we will analyze only 4 scenarios. If a mistake is made during the parametrization, the system detects it and alerts the user to prevent executing an experiment that could result in errors or inaccurate information. Once the error is solved, we can continue further. Finally, once the execution is complete, we can review the information presented on the panels. Additionally, there is an option to download the results as a text file in our format. This allows for a comprehensive analysis of the outcomes, enabling users to leverage R's powerful statistical tools for deeper insights. Whether you choose to analyze the data directly within the interface or export it for further examination, the flexibility ensures a thorough understanding of the results.